conveyor belt drive systems a design thinking approach. In modern industries, conveyor belt plays a vital role in material handling and automation. They plays a wide role in food processing unit, logistics sector, and material handling and etc. So in this, maintaining a constant speed and speed control is the main challenge in conveyor belt systems. For overcoming this problem, we are implementing a closed loop conveyor belt system. So for this, we are empathize the part of solution. So now we are going to explore the empathy part of this problem.
Empathy, understanding industrial needs. Let us consider the manufacturing plants. So in this there are three categories: raw materials, packed products, and heavy mechanical compounds. So in this conveyor belt is used to transport materials from one section to another. So now let's think about that. And the industrials needs what happens if the conveyor belt is in pressure. So product may falls or collapse, and production timing is disturbed, and quality effect is controlled. So industries need four aspects. So first thing is the controls, constant speed, and then as smooth acceleration and stable operations. So these are the real industrial needs experts.
So now let's move on to the defining part of this problem.
So now defining the conveyor belt concept. A conveyor belt is driven by the help of. So defining the conveyor belt concept. A conveyor belt is driven by the induction motor or a DC motor. When an extra load is given to the conveyor belt, this creates some production inefficiency and also reduces the motor speed. So the problem is how to constant speed despite the load disturbances. So this is the concept of closed loop system.
So now let's move on to the ideal part of this challenge.
So we came up with two approaches to solve this problem. And our first approach is open loop system. So in this system, just consider you're giving a constant voltage to a motor where the speed is set. It doesn't increase or decrease. But what is the load increases or decreases? What happens? The speed changes. The system cannot change itself. So this approach cannot be reliable. Thus we came up with a smarter way, which is the closed loop system, our second approach. In the closed loop system, we measure the actual value using a sensor to achieve the required value. If the motor increases, the system decreases the input. Where the speed of the motor decreases, the system increases the input. So this is what happens in a closed loop system. To build this system, we need a reference input and the speed sensors which acts as a feedback, and PID controllers and comparators, and the motor drive.
So now let's move on to the prototype session of this problem.
Tell about how we are going to build a closed loop system, closed loop conveyor belt using the closed loop system. So first, let's take a reference speed of around 1500 RPM. Let's take it as that, and then we will use a tachometer or encoder as a speed sensor. Here the speed sensor acts as a feedback sensor. So let's take an example of a motor. We fit into the shaft of the motor. We will find some speed. Let's take an example of 1400. So 1500 is the reference speed and 1400 is the speed of the motor. So there is a difference of 100 RPM, which is the error, which will be compared by the comparator. Then that error will be sent. Then in this comparator, we will convert the mechanical energy into an electrical energy, and will be sent into a PID controller. What is a PID controller? It's the proportional integral derivative controller. In this, we will see mainly three parts: proportional, whether there is a present any error is there or not. In integral, we will see that whether the steady state error is right or not. In the derivative, we will find there is any that there might be a problem in the futuristic or not. We'll find it, and the electrical signal will be converted into the control signals in the PID controller. After that, it will go to the motor driver. In this motor driver, will be like changing the values like voltage or the voltage or speed or the torque. we'll be changing with a DC drive or a VGC drive. Then at the end, we'll go to the, after completing all the problem, if the speed is 1000, if the reference speed is 1500, the output speed should be 1500. Then there will be an error in the motor. So this is the prototype for the closed loop conveyor belt.
Let's move on to the testing part of this problem.
So now we talk about the testing part of a conveyor belt drive system. We have several factors that we have to analyze, like rise time, settling time, overshoot, steady state error and stability. If the conveyor is too slow, we have to increase the proportional gain, and if the speed is oscillating, then we have to adjust the derivative gain. If the steady state error still exists, we have to increase the integral gain. So this process improves the optimal performance. Just like the design thinking approach, we refine and improve the solution until the user meets the required output.
The conclusion part of this problem.
To conclude the problem, the closed loop control of a conveyor belt is a perfect example for applying control system principle in the real industrial problem. To solve this kind of problem, by using this solution, we can able to achieve high efficiency and from infatuation to saturation to stability, from delay to precise value, and inefficient to more efficient. Control system is not just an equation and circuits. It is an solution to run the industry smoothly. Thank you.
Thank you.